Welcome to our exploration of the biomechanics of human skeletal muscle. In this video, we'll dive into the fascinating world of how our muscles work, focusing on the behavioral properties of the musculo-tendinous unit. Whether you're a student of biomechanics or just curious about how your body moves, this journey will help you understand the science behind every stretch, contraction, and movement. Let's start by setting the stage for what makes skeletal muscle unique and why its properties are crucial for everything from walking to athletic performance. Get ready to discover the hidden mechanics inside your own body. Musculo-tendinous unit is a term used to describe the combination of muscle fibers and their associated tendons. This unit is responsible for generating force and transmitting it to the bones, allowing us to move. Understanding its structure and function is key to appreciating how our bodies perform complex movements. The interplay between muscle and tendon is what gives us both strength and flexibility. In the next scenes, we'll break down the specific properties that make this unit so special. One of the most important behavioral properties of the musculo-tendinous unit is extensibility. This refers to the ability of the muscle and tendon to be stretched or to increase in length. Extensibility is what allows us to reach for objects, perform yoga poses, or simply bend down to tie our shoes. Without this property, our movements would be stiff and limited. The balance between extensibility and other properties ensures that our muscles can adapt to different physical demands. Elasticity is another key property of the musculo-tendinous unit. After being stretched, muscles and tendons have the ability to return to their normal resting length. This is similar to how a rubber band snaps back after being pulled. Elasticity is crucial for efficient movement, as it helps conserve energy and prevents injury. When you jump or run, elasticity allows your muscles to absorb and release energy smoothly, making your actions more powerful and controlled. Let's take a closer look at the components of muscle elasticity. The parallel elastic component, or PEC, refers to the passive elastic property of muscle that comes from the muscle membranes. These membranes run parallel to the muscle fibers and provide resistance when the muscle is stretched. The PEC acts like a built-in safety net, helping to protect the muscle from overstretching and contributing to the overall elasticity of the musculo-tendinous unit. Series elastic component, or SEC, is another important part of muscle elasticity. This property comes from the tendons, which are connected in series with the muscle fibers. When a tense muscle is stretched, the tendons act like springs, storing and releasing elastic energy. The SEC is essential for activities that require quick, powerful movements, such as jumping or sprinting. Together with the PEC, the SEC ensures that our muscles can handle a wide range of physical demand. From a mechanical perspective, the musculo-tendinous unit can be modeled as a contractile component, the muscle fibers, working in parallel with one elastic component, the muscle membranes, and in series with another elastic component, the tendons. This arrangement allows muscles to generate force, absorb shock, and return energy efficiently. Understanding this model helps us appreciate the complexity and efficiency of human movement. Irritability is the ability of muscle tissue to respond to a stimulus. This property is essential for muscle function, as it allows muscles to react quickly to signals from the nervous system. When you decide to move, your brain sends an electrical signal to your muscles, which respond by contracting. Without irritability, our muscles wouldn't be able to react to commands, making movement impossible. Another critical property is the ability to develop tension. This refers to the contractile component of muscle function. When a muscle contracts, it generates tension that can be used to move bones and perform work. The amount of tension a muscle can produce depends on various factors, including its length and the type of contraction. This property is fundamental to all voluntary movements, from lifting weights to typing on a keyboard. Neuromuscular junction is where the nervous system communicates with muscle fibers. Here, electrical signals from nerves are converted into chemical signals that trigger muscle contraction. This specialized connection ensures that muscles respond precisely to commands, allowing for coordinated and controlled movements. The efficiency of this junction is vital for everything from reflexes to complex athletic skill. Electrical muscle stimulation is a technique that uses electrical impulses to activate muscles. This method is often used in rehabilitation and athletic training to enhance muscle performance or aid recovery. By mimicking the body's natural signals, electrical stimulation can help maintain muscle strength and prevent atrophy, especially when normal movement is limited. See muscle contraction in action. When you decide to move, a complex chain of events unfolds. Your brain sends a signal, your nerves transmit it to the muscle, and the muscle fibers contract. This process happens in milliseconds, allowing for rapid and precise movements. Whether you're running, jumping, or simply waving hello, muscle contraction is at the heart of every action. Every movement starts with a stimulus, such as a thought or a reflex. The muscle's ability to respond to this stimulus is what makes coordinated movement possible. This property is especially important in sports and daily activities, where quick reactions can make all the difference. The interplay between stimulus and response is a fundamental aspect of muscle behavior. Muscles are highly adaptable tissues. With regular use and training, they can become stronger, more elastic, and better able to respond to stimuli. This adaptability is what allows athletes to improve performance and helps individuals recover from injury. The behavioral properties of the musculo-tendinous unit play a central role in this process, supporting growth and resilience. Let's recap the key behavioral properties of the musculo-tendinous unit: extensibility, elasticity, irritability, and the ability to develop tension. Each property contributes to the overall function of muscle and tendon, enabling us to move efficiently and safely. Understanding these properties helps us appreciate the complexity of human movement and the importance of maintaining muscle health. Knowledge of muscle behavioral properties has many practical applications. In sports, it informs training techniques that enhance performance and prevent injury. In rehabilitation, it guides therapies that restore function after injury. Even in everyday life, understanding how muscles work can help us move more efficiently and avoid strain. The science of biomechanics is truly relevant to everyone. Maintaining healthy muscles is essential for overall well-being. Regular exercise, proper nutrition, and adequate rest all contribute to muscle health. By keeping our muscles strong and flexible, we can enjoy better mobility, reduce the risk of injury, and improve our quality of life. The behavioral properties of muscle remind us of the importance of caring for our bodies. Understanding how muscles and tendons behave can help prevent injuries. By recognizing the limits of extensibility and elasticity, we can avoid overstretching or overloading our muscles. Proper warm-up, stretching, and strength training are all strategies that support the safe function of the musculo-tendinous unit. Prevention is always better than cure. When injuries do occur, a deep understanding of muscle properties is vital for effective rehabilitation. Therapists use knowledge of extensibility, elasticity, and tension development to design recovery programs that restore function and prevent future problems. Rehabilitation is a process that relies on both science and patience, helping individuals return to their best selves. The field of biomechanics is constantly evolving. New research is uncovering even more about how muscles and tendons work, leading to better treatments, smarter training methods, and innovative technologies. As we continue to learn, the potential for improving human movement and health grows ever greater. The future of biomechanics is bright and full of promise. Conclusion: the behavioral properties of the musculotendinous unit are at the heart of every movement we make. From the ability to stretch and return to shape, to responding to stimuli and generating tension, these properties enable us to live active, healthy lives. By understanding and respecting the science behind our muscles, we can unlock our full potential and move through life with strength and confidence. Thank you for joining us on this journey into the biomechanics of human skeletal muscle.